Hi, and welcome to the Mentored Engineer. When I was a young engineer about 20 years ago, I had to call our local steel supplier and buy some steel for a prototype that we're making. Really didn't have any idea what I was doing on the phone with them, and they kept asking me question after question, and I had no idea. So I wanted to save you the hassle of not knowing what you're talking about when you call and order some generic steel for your next project. Hey, if you like what you see so far, please be sure to smash that like button and subscribe and click that notification bell so I can annoy you at least once a week. So the first thing you need to get is a steel book. It's very important. All right, this one I got in about 2002. It's all but done worn out. I take very good care of this so that it does not wear it any further. This is a Ryerson tool stock list. They have this still, even if it's not your local steel supplier. I think you can buy it for $20 to $25. Well worth the investment. Get your boss to pay for it. And you will use this all the time if you specify steels. All right, you can also download a digital copy of the Ryerson one at least. But just me, I like to have something I can flip through, and I know exactly where everything is in this book because I've been using it for 20 years. So steel comes in 5 main types: pipe, tubing, bars, plate steel, and structural shapes. Let's talk about pipes. Pipes is probably the least customizable one. You get your OD that you can customize, and you get your thickness. So pipe is very weak compared to the other steels, and it's generally only available in 32 to 35 KSI. So if you've ever been to a hardware store, you notice that 3/4 inch pipe doesn't have a 3/4 inch dimension on it, unless of course you cut it to 3/4 of an inch. The reason for that, I'm actually not sure of. One thing I do know is that in the smaller sizes, if you have a 3/4 inch pipe, the ID is about 3/4 inches when you have schedule 40. This brings me to my next point, is that the thickness of pipe is measured in schedules. You have, generally speaking, 10, 20, 40, 80, 120, and 160. With that said, the OD of pipe is well toleranced, but the ID is allowed to free float as much as it needs. Let's move on to bar, because bar is where we're going to spend a lot of time. So bar is definitely the most customizable type of steel. Bar steel consists of round bar, square bar, rectangular, and hexagonal. Now bar steel is specified with an alloy number, which is a 4-digit number. The 4 digits are then separated into two 2-digit groups. The first 2 being the alloy number, and the second 2 being the carbon content. For the alloy number, generally speaking, 10 is the lowest. That's a plain carbon steel. There isn't much in it other than carbon and iron. As you increase in number, the next one would be 11 and 12. These are usually like screw stock type items. And then you can get into higher alloys, 41, 43, 86. And there's others sprinkled in there sporadically as well, but those are the big ones. The higher the number gets, the more complicated your steel is, and of course, the more it costs. On the other 2 digits is the carbon content. And so here's the deal with carbon. As you increase the carbon content, you're going to have a better, stronger alloy, but it's going to be harder to weld. Once you get up to 30 is the cutoff for easily weldable steels. After that, you're going to have steels that you can do with, and that pretty much goes up to 50, maybe even 55. But these require special process. First of all, you're going to need to use special weld wire. You're going to have to preheat your materials, and then you're going to have to do a controlled cool down. All of these things have to be done exactly right, otherwise you're going to crack that weld as it cools. Another thing to look for in weldability of steel is your ductility. You're going to want at least 10% ductility in your steel. So that means you're going to want lower grade alloys and lower carbon contents.
So saying nothing new here, you're just going to want to do a double check with your ductility. All right, now let's talk about the forms that it comes in. The most common one is hot rolled. So with hot rolled, the steel comes right out of a mill, and it's gonna have your top and bottom surfaces flat. For bar, it's gonna be fairly round, but it's not gonna have really tight tolerances. In fact, the ends of a square or rectangular bar are gonna have just rounded corners. They're not gonna look very good. The next step up is cold drawn. In cold drawn steel, it'll come out of the mill as a hot rolled, and then they'll put it through another set of rollers to ease it down to a smaller diameter, and that diameter will have pristine square corners, and it's going to be nice. You're also cold working it, so when you take say 1018 from hot rolled, it's at 32 KSI. That's now going to be 54 KSI as a cold drawn bar. Now I like to remember the difference between cold drawn and hot drawn is if you drop some cold drawn steel on your foot, it's going to cut it off. It's going to have that nice sharp edge to cut it off. Hot rolled, it's just going to smash it because it's got that nice smooth corner, and it's just going to smash your foot. Hey, wear steel toes though, okay? Another option is quenched and tempered. So this would take a piece of cold drawn bar, and it would take it up to an elevated temperature and stress relieve it, and then you're going to temper it in a very specific thermal way to get even higher strength out of it. Now, generally speaking, this is reserved for your higher alloy steels. This is where your steelbook comes in handy to see which ones it's available in. So bar stock also has another cool option, especially in the round bars, where you can get different surface finishes attached to it right from the steel mill. One of the popular ones is chrome plating. Chrome plating is great for surface hardness, and this is a material that's widely used with cylinder design and with pins. Now let's move on to tube steel. Tube steel has the same 4-digit identification that bar does, the most common being 1020 and 1026. Also available in hot rolled and cold finished. There's actually another opportunity there as well. This is drawn over mandrel, or DOM. Now this is very similar to the cold working process. It's different though, where it controls the OD and ID very carefully, and you can get strengths up to 72 KSI yield. These are the most expensive as far as tube steel goes. Now, aside from round tubing, you also have square tubing and rectangular tubing. Rectangular tubing is generally available in ASTM 500 grade B, not the 4-digit code we were just using. The 500 grade B is a 46 KSI, and you can actually get grade C, which is up to 50 KSI. One of the things about tube and how it's processed is it's very sloppy as far as the tolerances are concerned. There's really no radius control. You're forming it over, and sometimes there's a weld seam on the inside. So if you're running a tube inside of another tube, it's very difficult to get that. Although you can specify that that is ground off before you receive it, for additional money, of course. So be careful with square tubing. It is not very tightly toleranced, and if you have your steelbook, you can look up those tolerances. So the great thing about steel tubing is you can get it anywhere, and it is readily weldable, so perfect for your next welding project. So unlike pipe, one of the great things about tubing is that it is actually specified by its dimensions, so there's no guessing as to what the actual size is. All right, so if I have a 3-inch by quarter tube, I expect a round tube, 3 inches OD, 1/4 inch wall, theoretically 2.5 inches ID. For rectangular or square tubing, if I have a 3x2 by quarter, I expect a piece of rectangular tube that's 3 inches by 2 inches by 1/4 inch thick. So let's move on to plate and sheet steel. Both of these are pretty much the same. Plate is generally thought of as coming in fractional or millimeter thicknesses, and sheet steel comes in gauge thicknesses. Gauges are backwards, just like electrical wire is. The lower the number, the thicker the wire is. Same thing with sheet steel. So 7-gauge sheet is much thicker than 16 gauge. In fact, 7 gauge is 0.1793 inches thick and 16 gauge is 0.0598. Plate and sheets are great because you can cut these with laser cutters or plasma cutters. It's available in a variety of thicknesses, and you can get it in many width and length sheets, all the way up to I think 6x40, possibly even bigger. I mean, the one thing that you're limited by is the truck that's going to ship it to your facility. As you can see here, it's also available in continuous coils. The last group of steels are structural shapes. Most people know these as I-beams, which are classified as W, M, and S shapes, as well as angle and channel. With structural shapes, you're going to have a 2-digit identifier. The first digit is going to be the approximate height of whatever it is. So with a wide flange W-beam, you're going to have, say 8 inches, and it may vary from 7 3/4 up to 8 1/2, depending on what size you're getting. So it's about 8. And then the second number is going to be the weight per foot. So if I go and look up in my steel book a W8 by 18, I know that it's about 8 inches tall and it weighs 18 pounds per foot. Shipping channels are the same. This is your standard C channels. They're going to come in and the height of the back and then the weight as well. So angles are a little bit different. They're actually measured by the dimensions. So if I have a 2x2 angle, I expect both legs to be 2 inches and then the thickness to be 1/4 inch. So with structural shapes, what you're going to want to look out for is they're not perfect shapes. Channels have tapered flanges, that's this part, so they actually get thicker and thicker as you go towards the back. Angles have rounded edges everywhere except for the back corner. And I-beams have radiuses all over that thing. All right, so I hope this video gives you enough information about selecting a steel that you don't look like a complete idiot when you go and order something. Thank the Mentored Engineer. So thank you for watching this episode of the Mentored Engineer. Be sure to hit that like button and click the subscribe if you haven't already. Thank you for watching.